Adhesion is a property that describes bonding strength between two materials. There are various methods to measure adhesion properties of materials, depending on the application requirements and product specifications. In this video, we will describe various industrial methods of measuring adhesion and the applications they are applied in. There are many customer-based tests to quickly evaluate a material's adhesive performance. For example, conformal coatings may be evaluated by trying to scratch the coating off, but that may be measuring tear strength or toughness instead of adhesion. Another example is a customer peeling off an adhesive by hand. These examples are useful for getting a quick estimate of adhesion quality, but both are qualitative, making it difficult to compare performance between products on devices. The main types of adhesion testing used with silicones for electronic applications are lap shear, peel, push-out, and crosshatch. Lap shear adhesion is a very common test method for measuring adhesive strength. Sample preparation consists of curing an adhesive between two substrates at a specific thickness. Material is first applied to a substrate, then a bond line thickness setting material is added, in this case glass beads, to achieve the required thickness. Next, a second substrate is compressed onto the adhesive. The stack is then cured and ready for testing. The test consists of pulling the two substrates apart at 180 degrees and measuring the force required to pull them apart. Typically, the substrates overlap by 1 square inch. Since the material is confined between substrates in lap shear testing, it is not the most ideal method for testing moisture cure products. These products require moisture in the air to cure, and due to the confined overlap, curing rates will be much slower, sometimes taking weeks to cure a sample. To mitigate this, smaller overlap dimensions are used with 1/2 inch overlap to cure samples in 1 week. Lap shear samples must be carefully constructed to produce accurate, reproducible results. Substrates that are cured at an angle or samples that have non-uniform bond lines can result in increased measurement error. For standard adhesives, the bond line can be varied and should be tested at the desired application thickness. To achieve the required bond line thickness, glass beads, wires, or specialized jigs can be utilized. Peel adhesion testing is a very common method to measure adhesion of thin coatings and moisture cure sealants. Peel testing consists of curing an adhesive between a rigid and flexible substrate. After curing, the flexible substrate is peeled away at either 90 or 180 degrees from the rigid substrate. The flexible substrate is typically a mesh, screen, film, or fabric. Peel adhesion can be run directly on devices and parts. It is much less sensitive to bond line thickness or flatness and can even be run directly over circuit boards to test adhesion of gels and encapsulants. Peel and lap shear adhesion values should list cure conditions, the substrate tested, the strength value per square area, and ideally if the material pulled off cleanly, called 0% cohesive failure, or if the adhesive tore within itself, called 100% cohesive failure, or some combination such as 0 to 100% of the bond area. Push-out adhesion testing is another method to measure a material's adhesive properties in gasket form. A material is dispensed around a circular window, and a top layer substrate is adhered to the gasketing material. After curing, a texture analyzer is used to push out the top layer substrate through the circular window, and the resultant forces are measured. Push-out adhesion is mainly used for hot melt products for applications where this more closely mimics actual application stresses. Hot melt adhesion testing can be done as soon as the adhesive cools, but strength will typically build over several days. Crosshatch adhesion is another test that is commonly used for paints and very thin coatings such as conformal coatings. A special tool with sharp blades is drawn over the cured coating in one direction, and then again at 90 degrees to create a grid of cut lines. An adhesive tape that sticks strongly to the coating is then applied and pressed on firmly. This tape is then peeled off. Strength is not usually measured, but percent cohesive failure can be obtained by counting the squares where the coating remains bonded to the substrate. With all adhesion testing, substrate should be clean and not have any mold release. Some surfaces may require plasma or primer treatments to obtain best adhesion. Full adhesion is only obtained after full cure. Test cure conditions to optimize adhesion. For heat cure products, in general, the hotter the cure temperature, the better the adhesion. Samples should be cured completely prior to adhesion testing. Stronger adhesion is usually better, although applications may not need as much strength as the adhesive may offer. Percent cohesive failure relates to how good of a seal is made. If the main job of the adhesive is to seal, then the percent cohesive failure may be more important than the strength. In this video, we covered lap shear, peel, push-out, and crosshatch adhesion testing methods. As with all validation testing, the methods selected should closely match application stresses.